So here is the example of system of linear ODEs. So we have example 1 that is given as, suppose the first ODE is dy1 over dt is equal to minus c1 y1 plus y2 is equal to ft f1t d y2 over dt is nothing but minus c2 y1 plus y2 is equal to f2t. So in case of explicit formulation, my y1 n plus 1 minus y1 n divided by delta t becomes c1 y1 n plus 1 plus y2 n plus 1. No, this value will be evaluated at time n plus f1 tn, and my y2 n plus 1 minus y2 n divided by delta t will become c2 y1 n plus y2 n plus f2 t n. This implies my y1 n plus 1 will become y1 n plus delta t times c1 y1 n plus y2 n plus f1 t at n. y2 n plus 1 will become y2 n plus delta t c2 y1 n plus y2 n plus f2 t n. So this is my explicit formulation. Now let us go to the implicit formulation. The implicit formulation says that the first ODE is dy1 over dt is c1 y1 plus y2 plus f1t, and the second ODE is dy2 over dt is equal to c2 y1 plus y2 plus f2t. So implicit formulation says that y1 n plus 1 minus y1 n divided by delta t is c1 y1 n plus 1 plus y2 n plus 1 plus f1 t n plus 1, and y2 n plus 1 minus y2 n divided by delta t is c2 y1 n plus 1 plus y2 n plus 1 plus f2 t n. This implies we have 1 minus c1 delta t y1 n plus 1 minus c1 delta t y2 n plus 1 is equal to y1 n plus delta t f1 t n plus 1 minus c2 delta t y1 n plus 1 plus 1 minus c2 delta t y2 n plus 1 is equal to y2 n plus delta t ft n plus 1. So that eventually lead to a matrix, and this is a matrix that will come out of these two equations: 1 minus c1 delta t minus c1 delta t, so minus c2 delta t, 1 minus c2 delta t will be y1 n plus 1 y2 n plus 1 is equal to y1 n plus delta t f1 t n plus 1 y2 n plus delta t f2 t n plus 1. And at each time step we will solve this matrix to get the new values of yn plus 1 and y1 n plus 1 and y2 n plus 1 using the old values and the time step and c1 and c2 constants. So this is how we can calculate the solution of system of first order linear ODEs. Okay, in the next video we will talk about nonlinear ODEs, where first we will talk about the first single nonlinear ODE, then in the subsequent video we will talk about the system of solution of nonlinear ODEs. So before going to the next video, I can say that when we do the implicit and combined implicit explicit formulation, that is Crank-Nicolson, so in that case also we will get the matrix, because that will also have the So in that case, what will happen? This C1 del t will become C1 by 2 del t, and C2 del t will also become C2 by 2 del t. And in the right hand side of this matrix, we will be having this del t will be divided by 2, and in addition to that we will be having 1 by 2 C1 y1n plus y2n plus f1tn, and here we will be having C2 in addition to this del t by 2 f2tn plus 1, we will be having C2 y1n plus y2n plus f1tn, or sorry, C2 y1n plus y2n. So because in the second row the value will come from here. So what we will have y2n plus del t by 2 f2tn plus 1 plus C2 by 2 y1n plus y2n plus f2tn divided by 2. In the first row we will have y1n plus del t by 2 f1tn plus 1 plus C2 by 2 y1n plus, sorry, in the first row this will come C1 by 2 y1n plus y2n plus f1tn, and here this will be divided by 2, this will also be divided by 2, this will be divided by 2, this will be divided by 2. So in case of Crank-Nicolson formulation we will get the matrix, but the form of the matrix will be different. You can easily do the algebra of Crank-Nicolson. I'm not going to do that because that will be unintentionally or unnecessarily increase the length of the video. Thank you.